All right, let's find two equations for this graph. Now, notice on this one, we don't have multiples of pi along the x-axis. What we've got are just regular integers. So let's do a sine and then let's do a cosine. To me, the most logical place to start would either be here or here. Now, I think that's the best place to start right there, because if we start there, then we're dealing with a sine wave that is not flipped upside down. So if we start there, starting here, our amplitude, well, the amplitude is, let's see, how high up does this go? It goes up 1, 2, 3. So the amplitude is 3 and it's not shifted, or it's not flipped. So A is going to be 3. Now my phase shift, that's at -2. So the phase shift's -2. And the period, on this one we can probably just count off what the period is. If we go from here to here, that's one full period. And I'm just going to count across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the period's 10. So let's work out what B and C are. Now B is, we know that the period is 2 pi over B. So if we take this as an equation and solve it, you get 10B equals 2 pi. So B is 2 pi over 10 or pi over 5. And then the phase shift is -2. And phase shift is C over B. And let's see, B in this case is pi over 5. So -2 equals, tell you what, I'm going to put it over here, C over pi over 5. So I'm going to bring this down. This is -2. C divided by pi over 5, that's going to be 5C over pi. So C is going to be, so you got -2 multiplied by pi divided by 5. So that's my C. So this gives me the equation y equals 3 sine pi over 5 x minus -2 pi over 5. So plus 2 pi over 5. Let's see if that's right. Let's see, I'm going to reload Desmos to get it back to the usual just numbers along the x-axis. Let's see, y equals 3 sine pi over 5 x plus 2 pi over 5. All right, let's compare that to our original graph up here. Let's see, it starts at -2. It has a max of 3. And that happens at 1/2, which, yeah, that looks like it's right. And let's see, what is this? That's at 3. And if I come up here and mark the same point, that right there is also at 1, 2, 3. And this ends at 8. And this also ends at 8. So yeah, that's correct. All right, the question said, though, find at least 2 equations for this graph. So let's find another one. We could either do another sine, or let's do a cosine. Let's say that we let's do a cosine graph. I'll do this in black. It starts here and ends here. All right, so if we look at that, you can kind of look at it and tell that's at 1/2. I'm kind of cheating there because I saw it on the graph of the other one. Well, on the graph that we just looked at on Desmos. But anyway, that's at 1/2. So if we go with this point, this is a phase shift of positive 1/2 because it's moved over. And the period is the same as it was before. The period's still 10 because we go from 1/2 here to 10.5 here. So phase shift of 1/2, and the amplitude is still 1. So let's come down here and write that out. Or I'm going to copy it. Down here, paste. All right, so we've got that stuff. Actually, we don't need to recalculate b. b is pi/5. A is still 1. The only thing left to recalculate is c. So let's see, c over b is, that's the phase shift, so it's 1/2. I'm going to replace this b with pi/5. So 2c equals pi/5. So c is pi/10. Pi/10. Yeah. All right, so this would be y equals, wait a second, I said a was 1. That doesn't sound right. Yeah, the amplitude's not 1, the amplitude's 3. So it's 3 cosine of pi/5x minus pi/10. So let's graph that and see if we get the same thing. All right. So y equals, next line, y equals 3 cosine pi/5 x minus pi/10. And yeah, we got the exact same graph there. So yeah, that's a cosine curve that gives us the same thing. All right, we've got 2 more examples. I think I'm going to do these examples, just one example per video.